Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem. Find the first node of loop in linked list. Okay, so let's see. So let's see through an example. So what the problem is saying is we'll be given a linked list. Okay, and what we want to do is we want to find out the start of the loop, the start node of the loop. So for example, if this is the linked list, right? So there's a loop, right? So where's the loop? Loop is here, right? Loop is here. Okay. So what the problem is saying is we want to find out the first node of the loop. And which is that particular node? That is this particular node. This is the start of the loop, right? So we want to return this particular node. Okay. So this is the ask. Okay. Now let's see various approaches. First of all, let's see the naive approach. So naive approach, again, what it is going to be. We'll take an extra space. Let's say we take a hash set. Okay. And what we're going to do, we are going to keep on pushing each node. Okay. First, before pushing, we are going to check is this particular node part of hash set or not. Okay, if it is, that means it is the start of the loop. That means it is the start of the loop. Let's see how it plays out. Okay, so we'll go to the next node. So we're going to check is 3 part of this particular set. No, it is not. So we'll push this particular 3. Okay, then we're going to check is 2 part of this particular hash set. No, it is not. We will push it into the set. Okay, then we're going to check is 4 part of no, it is not. We are going to push it into the hash set. Then we're going to check for 5. No, it is not. We'll push this into hash set. Okay, now the next of 5. What is the next of 5? It is 3, right? So this 3 we're going to check is 3 part of this particular hash set. Yes, it is part of this particular hash set. Okay, that means this has arrived before this particular node. This particular node had arrived before, and hence this is the start of the loop. Okay, and hence we're going to return this node 3. Okay, now coming to the time complexity, what will be the time complexity? It is going to be O of n. Okay, and what will be the space complexity? It is going to be O of n because we are taking extra space in terms of hash set. Okay, so we want to find out whether there's any better approach in order to solve this problem without taking any extra space. Okay, so let's see. Let's see how can we solve this problem. Okay, let me erase this. Okay, now what we are going to do? What we are going to do? Again, we are going to let me write this linked list here. 1, 3, 2, 4, and 5. And we will, there's a loop this, right? So what we are going to do, we are again going to take 2 pointers, slow and fast. Okay, this fast pointer will move by 2 nodes. This slow pointer will move by one node. Okay, let's see. So here we are going to, first of all, the first step is move fast pointer by 2 nodes. Okay, okay, and move slow PTR, the slow pointer, by 1 node. Okay, by 1 node until they both the pointers, right? Until both the pointers, fast and slow, meet at some node. Okay, at some node. So this is the first step. So let's dry run this. So slow will move by 1 node as discussed. Slow will be here and fast will move by 2 nodes. Fast will move by 2 nodes. Again, slow will be moved by 1 node. Fast will move by 2 nodes. Fast is here. Okay. At 5, node 5. Okay. Then again, let's move slow. Slow will be here and fast will move by 2 nodes. That is 3 and 2. Fast will be here. Okay. Then slow again will move by 1 node and fast will move by 2 nodes. Slow and fast. So if you observe here, now both slow and fast are pointing at this particular node 5. Okay, so this was the first step. We have to move fast pointer by 2 nodes and slow pointer by 1 node until they meet at some node. So here they are meeting. So once they have met at this particular node, now what we're going to do, let me write this list again. 1, 3, 2, 4, and 5. And here we have this loop, and fast was here, both fast and slow, both are here. Now, second step is when they meet at some node, then what we want to do is we want to initialize slow with head again. That is, we have to move the slow to the start of the linked list, which is the head, right? fast will be here as is on this particular node, and slow will be here, this particular node. So now the only change what we're going to do, we made two changes. So we moved slow to the head, and now the second thing is we'll now move fast pointer by one node only, both slow and fast pointer by one node only. So now by doing this, whenever they meet at some node, that will be the start of the loop, we'll say. Let's see how. Okay, let's see how. Now slow is pointing here, fast is pointing here. Now I'm moving slow by one pointer and moving fast by one pointer. And if you see, both are meeting at the same node 3. Okay, so when they meet in the second step, when they meet at some node, so that will be the start of the loop. Okay, that will be start of the loop, and we are going to, hence we are going to return this particular node. Okay, you can try with other example. Definitely this will prove right. Okay, now this was the intuition behind solving the problem. I hope you've got the intuition. Let's go and code. You'll understand better. Before that, let's discuss time complexity is going to be O of n. Space complexity is going to be O of 1, because we are not taking an extra space. We are just taking 2 pointers, slow and fast. Okay. So this is the intuition. Let's go and code. Okay. So before going to the code, I'll just request to please subscribe to the channel, like the video. First, I'll show the Java code followed by C++. Slow equal to head. Node fast equal to head. Right. We're going to have a for loop fast, where fast is not equal to null, because fast will, if there's no loop, then definitely fast will reach to the null or to the end of the linked list first, right? That is why we have to make these checks. Okay, and fast dot next, for example, since we are moving fast by two nodes, it may be the case that fast dot next can also be the null. That is why we have to make the checks. Slow equal to slow dot next, fast equal to fast dot next. Okay, so when slow and fast pointer meet, the step 1 is done. Now step 2 is we want to move the slow pointer to the head. Okay. Okay. Now what we're going to do, we are going to run a while loop until slow and fast both pointers meet. Okay. So and here both slow and fast pointer will move by one nodes only. Okay. Will move by one nodes only. And when this while loop breaks, okay, this while loop breaks, that means both slow and fast are pointing at the same node, and that is the start of the loop. Okay, slow, you can return anything, slow, you can return any. Okay, you need to return both slow and fast. You can return anything, both slow or fast pointer. And for example, if there's no loop, then we have to return null. Okay, that's it. Let's compile this. I think there was some disconnect which happened in between. Let's submit this. Okay, thanks for watching. I hope you've got the solution. Please don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code as well. Not much difference. I've already explained this, right? Only difference is null. We use null PTR in C++, and then we use asterisk for the nodes and arrow pointers. Okay, to refer to the next pointer. Okay, so thanks for watching. I'll attach the code into the description section. Please subscribe to the channel, like the video. I wish you a very happy, healthy, and a great day. Thank you so much.